Hello and welcome to Atomic. Humanity is finally ready to leave Earth behind. But there is one massive problem. We are running out of gas. Every rocket we launch today must carry almost all its fuel from Earth's deep gravity well. That leaves almost no room for crew, cargo, or long journeys. To reach Mars sustainably, to explore the outer planets, and to dream of the furthest stars, we need fuel stations already waiting in deep space. The solution? Mining comets. These icy giants are frozen reservoirs of water, the single most valuable resource in the solar system. Split water into hydrogen and oxygen, and you have high-efficiency rocket propellant. Today, we go step by step through how we are going to capture these speeding cosmic icebergs and turn them into the first fuel stations of the cosmos. Current rocket physics are brutal. To escape Earth's gravity, a rocket must carry 90–95% of its mass as fuel. That leaves almost nothing for payload or crew on long trips. Water changes everything. 1 ton of water can be split into 111 keys of hydrogen and 889 keys of oxygen, enough high-efficiency propellant for powerful engines. Comets are packed with water ice, carbon monoxide, ammonia, and organics. They are literally floating gas stations scattered across the outer solar system and the enormous Oort cloud. The challenge? Catching them. Comets move at 2070 km/s. Matching that velocity requires precise gravitational slingshots, next-generation ion drives, or even nuclear propulsion. Landing on a low-gravity, spinning, dusty nucleus is like trying to dock with a fragile snowball in the dark. Once we match speed, docking begins. The comet nucleus is dark, dusty, and fragile. There is no solid surface. We use harpoon anchors, nets, or magnetic clamps to secure the spacecraft. Then pressurized collection tents encapsulate the extraction site to trap every molecule of precious gas before it escapes into vacuum. Thermal mining is the key technique. Concentrated solar mirrors, or small nuclear heat sources, gently sublimate solid ice directly into water vapor. Advanced filtration systems remove comet dust and silicates so the raw water is pure enough for electrolysis. Onboard units split the water into hydrogen and oxygen. Cryogenic cooling chambers then liquefy the gases for long-term storage. In a matter of hours, a random comet becomes a floating gas station. Automated docking ports allow passing spacecraft to refuel without ever returning to Earth or lunar orbit. This infrastructure enables a permanent human presence on Mars and creates a gateway to the outer gas giants. Strategic comet outposts form a bridge of logistics that drastically reduces cost and travel time for deep space missions. By mastering the comet economy, humanity shifts from planetary explorers to a true spacefaring civilization. The Oort cloud alone contains trillions of comets, enough water and volatiles to fuel millions of missions for centuries. We're not just visiting space anymore. We're building the infrastructure to live there. Comets are not just dirty snowballs. They are frozen memories of the solar system's birth and the fuel for its future. If we succeed, the stars are no longer out of reach. The cosmos becomes a highway. What do you think? Will mining comets be the key that finally unlocks Mars and the outer planets? Or is the engineering too difficult and will stay trapped in the inner solar system? Drop your thoughts in the comments below. The most interesting theory gets a shout out in the next video. If this deep dive into the future of space travel blew your mind, smash that like button, subscribe, and hit the bell so you don't miss the next chapter. Thank you for traveling with me to the edge of the solar system. And keep looking up. The comets are waiting. See you in the next one.